Okay, I'm going to show you another sneaky trick for graphing parabolas using the vertex method. And I'm going to start off by trying to show you a pattern that shows up. And I want you to notice this is the very basic parabola where you have x squared. So I've created a table of values from -3 for x to +3. Our vertex for the very basic one is, of course, at 0, 0. And here's what I want you to notice. As I go out from my vertex horizontally and then go to my each step in the parabola, I go out 1 and up 1 for my first one. And then I go out 1 and up 3, out 1 and up 5. And I want you to notice what happens as I add some more values. If I go to 4, okay, so from 9 to 16, so I went 1, 3, 5, 7 is the next step. Notice that I'm going up by odd numbers, the next odd number. I'm going a sequence of odd numbers. 4 to 5, I go 16 to 25 for my y value. 16 to 25 is a change of 9. So again, 1, 3, 5, 7, 9. I go one more. 25 to 36 is 11. So 1, 3, 5, 7, 9, 11. The next one will be 13. 36 to 49 is 13. The next one will be 15. 49 to 64 is a step of 15. So there is a regular pattern. If you have your vertex and our a value, that coefficient of the squared part of this thing is 1, then we're going to have just this step system. We're going +1, +3 more, +5 more, +7 more, and so forth. Okay, so that helps us a lot if we have a parabola, if we have one of these ones like number 4. Okay, so number 4 is going to have, we've got x plus 2 squared minus 4. So our a value is 1, and we know what our vertex is. Our vertex is going to be -2, -4. So let's go ahead and plot that on here. I'm going to go ahead and plot that. So instead of having just x squared, I'm going to have this other one from number 4. So I've got, remind myself, that was on -2 and -4. So I've got a point at -2 comma -4. Right, let me move my graph so we can see that point. Great. So what I would predict for this one, based on this pattern, is this one is going to basically match this. So I'm going to have a point that's, if I go over 1 and up 1 and back 1 and up 1. So I should have a point at -1, -3. And I should also have a point going in the other direction at -3, comma -3. So you see this pattern here matches this pattern. So over 1, up 1. My next one should be over 1, up 3, which is going to put me here at 0, 0 and -4, 0. Okay, so I'll go ahead and plot those. 0, comma 0 and -4, comma 0. And if you look at this, these two kind of match, right? So we'll probably have another one. If we go one more step past that, go one more step past here, it should go over 1, up 5. So I should have a point at 1, 5 and at -5, 5. So I'm going to go ahead and plot that. 1, comma 5 and -5, comma 5. So I'm just following the pattern of a basic parabola, a basic x squared function that's been transformed to the left 2, and down 4. So my vertex is moved from here over and down. So let's confirm that, and let's see if that actually matches. Actually, that's a little too busy. That actually matches our parabola. Okay, so I've got y equals, I'll put in a 1 just to remind you that that is the a, x plus 2 squared minus 4. And it matches very nicely. Okay, you might be thinking, okay, great, but what if it's not 1 here? What do I do if it's 2 or 7 or 1/2? Well, if that's the case, each one of these steps is changed by that scale. So if it's 2, I'm going to double this. So let's turn this off, and I'm going to show you that with the base parabola. So here I have my base parabola. I'm going to add to this table. This is something you can do with these tables. We can add another column. And instead of 1, I'm going to say 2 times x squared. And I'm going to go, okay. Oops. Okay, and now I've got my table of values. So my first step, I go over 1, and instead of up 1, I go up 2. My next step, instead of going up 3, I'm going to go up over 1, 1, 2, 3, 4, 5, 6. So instead of 3, I go 6. My next step, instead of going up 5, over 1 and up 5, so 3, so 1, 3, 5, 7. My next step, instead of going up 5, I'm going to go up over 1. Instead of 5, I'm going over 1, up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you might have noticed that all I'm doing is I'm doubling that each odd number step. So instead of 1, 3, 5, 7, 9, 11, I'm going to go 2, 6, 10, 14, 18, 22. And we can even test that. We can look at here. So it went up 2, up 6, up 10, up 14, up 18, up 22, then it'll be up 26, and then it'll be up 30. So we're just doubling that odd number thing. So we can apply that to another one of the problems that's in here. So let's go in here and find one that doubles. Find one that doubles. There's one that doubles. Number 12 doubles. So this A value is going to double the pattern. Okay, so I know my vertex is going to be at 3, 1. So I'll go ahead and plot my vertex for that one. Turn that one off. I've got a vertex at 3, 1. Confirm that's right, because my function is, yes, 2 times x minus 3 squared plus 1. That h is 3 and k is 1. So I've got a vertex at 3, 1. Okay, now I know that I'm doubling that odd numbered pattern. So if let's go to 3, 1. Oh, it's not showing because that. Okay, so instead of going over 1, up 1, I'm going to go over 1, up 2. And I'm going to do that on the other side of this as well. So I'm going to go over to 4 and up 2 to 4, 3, and also to 2, 3. So let's see if that works. So okay, so I've done that. So if you look here, this is my double, my 2x squared, and it matches. So over 1, up 2 instead of over up 1. Now I'm going to go over 1, and instead of up 3, I'm going to go up 6. So from here, that's 2, 4, 6. So I'm going to get to 9 for that. So I'm going to be at 5, 9, and I should be at 1, 9. So we'll test it out. 5, comma 9, 1, comma 9. And if we move down a little bit, okay, so we have something that matches this pattern, just over 3 and up 1. Okay, because our h is 3 and our k is 1. So let's go ahead and test this parabola. I could keep going, but we'll go ahead and graph this. So it's 2 times x minus 3 squared plus, actually right now you can already see it's lined up underneath it. So plus 1, and it matches. So I didn't have to do any calculations at all other than just counting. So once I know the vertex and I know my A value, I know I'm going to have a pattern that just doubles that sequence of odd numbers. Instead of 1, 3, 5, 7, 9, it goes 2, 6, 10, 14, 18, and so on. So you can get your points that way. All right, cool. What if instead of times 2, it's times 1/2? All right, well, let's test that out. Do this, do this. Well, if I do over here instead of 2, I go instead of 2, I make that 1/2. Well, let's see what happens here. So I go over 1, up 1/2, over 1, up 1.5. So instead of over 1, up 1, I'm going half the way. Instead of over 1, up 3, I'm going half of 3, or 1.5. Now I'm going to go over 1, up to 2.5, or up 2.5 from 2, because 2 to 4.5 is 2.5. So instead of going up 5, I'm going half of 5. Now you could predict we're going to go up half of 7, which is going to be 3.5. So 4.5 plus 3.5 is going to be 8. And yes, we're at 4, 8. So we can use the same pattern for ones that are halvesies. Okay, I'm going to leave this in here without those labels, and we'll test one out from the homework that has halves instead of, has a half as the A value. So we'll do number 8. Okay, number 8, our vertex is going to be at 2, -1, because our h is -2, and our k is, I'm sorry, our h is +2 because it's x minus h, and our k is -1. Okay, so let's go ahead and plot that. So we've got a point at 2, -1 as our vertex. Okay, so I'm going to go down here and plot 2, -1. So there's that point. Now I'm going to go over to x is 3, and instead of going up 1, I'm going to go up 1/2 to -1/2. So I'm going to have 3, -1/2. And since parabolas are symmetrical, it's also going to be -1/2 over here at 1. So I'll go ahead and do that. 1, -1/2. All right. And now I'm going to go up, instead of up 3 when I go over, I'm going to go up 1.5. And I'll end up at 4, 1. And I'll also end up at 0, 1. So 4, 1, 0, 1. And now instead of 1.5, I'm going to go up 2.5. So up 2.5. So that's going to be at 3.5. So 5, 3.5. So 5, 3.5. and I'm going to need to be at -1 because that's on the opposite side. Okay, because I was here, so I'm going to go over, back 1, and up 2.5, or half of 5. So it's going to be -1, 3.5, because that moves me up 2.5. I'll go ahead and do one more, so over 1 and up 3.5 now. So half, 1.5, 2.5, 3.5. I should now be at 6, 7, and on the opposite side, -2, 7. So 6, 7, and -2, 7. So now let's see if that actually works for what we have. So we know our vertex is here at 2, -1. I don't actually have to go back and look at it now because I know I'm going to have an x -2 and my k is -1. But I will go ahead and confirm that for you. Okay, so then we have x -2 squared, and then we get a -1. And we also had a 1/2. So it's going to be y equals 1/2 x -2 squared. Okay, and you can see it is lining up nicely there. And I'm going to change the color of these dots so they don't get confused with my basic function. Okay, so now I'm going to bring that down -1, and it lines up perfectly. Using this approach could save you a lot of time, improve your efficiency with graphing these things. Okay, if it had been a -1/2 here, we would be flipping over. So we would flip over our vertex point, so negative flips over right there, and all my points would be over 1, down 1/2, over 1, down 1.5, and then over 1, down 2.5, over 1, down 3.5, and so forth. So there are patterns that can be your friends here. I hope this has been helpful. I'm going to go ahead and pause this video and upload it.